Hey guys, today we're going to go over chapter 7, section 3, which is going to be logarithm functions. Now, the key concept is that logarithm functions you can rewrite into a different form in order to solve for it without a calculator. That is when the subscript or the base b is not 10, which is what your calculators have, but we're not working with calculators, so you need to learn how to move things around. The logarithm base b of a positive number x satisfies the following definition. For b is greater than 0, b cannot equal 0. So log b of x equals to y if and only if b raised to the y power equals 2x. So these are your two forms. This is your log form, and this is your exponential form. I'm going to write those down. This is your log form, or logarithm for long. I'm writing log to shrink it. And this is your exponential form. Now you can read log bx as log base of b of x. In other words, the logarithm y is the exponent to which b must be raised to get x. So here we have that you can write the exponential equation as a logarithm equation and vice versa. What does that mean? You have this b, which is going to be the subscript of the log. You have the exponent here, that's always going to be the equal of the log. You always have the a, which is going to be the base of the log. You can go both ways. So I'm going to write the arrows on both sides. So this is something that you can go back and forth with all the time. So let's do a few examples. We have an exponential form. I don't want us to write it in logarithm form. Now I will write the information we had before. So b x to the raised to the x equals to a. And we have log subscript b, a is equal to x. So let's figure out what we're going to do. If you're going from exponential to logarithm, you always want to write the word log because you're going to have it in every single answer. Now, after you write log for 1, 2, 3, in this case all of them, let's figure out what the base is going to be. The base is going to be this number right here, right, for all of them. So we're going to go ahead and write 3. We'll write the other ones as we keep going, but I'm just identifying what each one is. So 25, 10, 6, and a. Then we want to figure out what our a is for the log. So this letter right here, that's going to be the equal. So it's going to be all of these numbers and letters. So we're going to write 243. Here we can write 5. Here we can write 10,000. Here we can write 1 over 6. And here we can write c. Now, you have almost everything written for your answer. You're only missing what's equal. Now remember, what's equal is your exponent. So here you have your 5. Here you have your 1/2. Here you have your 4. Here you have your -1. And here you have your b. So all of these equations have been written from exponential into logarithm forms. Again, take it one step at a time. I was just showing you each step for all of them one step at a time. But if you don't understand, please ask me tomorrow when I'm in class, and or erase some of the problems since you have the answers on the video and work on them individually. Now I'm going to rewrite the exponential form that we had before and the logarithm form that we had before and write the information. Now the first thing you want to write for going from logarithm to exponential is the base. So I'm going to underline the base for all of these logs. So it's going to be 9, 2, 8, 4, and b. The second thing you're going to have on the exponential form is going to be your exponent, which is what the log is equal to. So I'm going to underline all of those. So we're going to get 9 to the first power, 2 to the 9th power, a to the 1/3 power, 4 to the negative 2nd power, and b to the 0 power. Now we're just missing the a, which is the number that we have left over. So we have 9 to the 1st power is equal to 9, 2 to the 9th power is equal to 512, a to the 1/3 power is equal to 2, 4 to the negative 2nd power is equal to 1 over 16, and b to the 0 power is equal to 1. Now, being able to transform them into logarithm or exponential functions is only the first step, as you can actually solve them. So here we're going to equal it. I'm going to equal it to x to figure out what we're trying to solve for. Now, I can't solve log base 216 because I don't have a calculator to solve it, and neither do you. So we're going to write it into an exponential function. First thing we're going to do is write that 2 to the x power is equal to 16. So what number gives us, if we raise 2, gives us 16? Let's figure it out. So we have 2 times 2, that is 4, times 2 times 2, that is 4, 16. So we have 4 2's. So our x is going to equal 4 because 2 to the 4th power equals 16. Now let's do log 8 to the 8. Again, I'm going to equal it to x just to have something to solve for. We have the base 8, and then to the x power is equal to 8. Now, because 8 is equal to 8 as a base, the only exponent that's going to work for here is 1. We're going to do the same thing for log 49. 7 is equal to x, so we're going to have 49 to the x power is equal to 7. Now, the only way you can get a bigger number to a smaller number is dealing with square roots. Now, we know 49 is a perfect square root. So, remember, square roots can be written as exponents of fractions. So, it's going to be 1/2. Our x is equal to 1/2. And then lastly, we have this equation that again we equal to 0. So, it's going to be 2 to the x power equals 2 to the 5th. Now, this last problem is something special. Because we have the same base, we can actually ignore the bases and just equal the exponents to each other. So we get x is equal to 5. Okay. Now, please make sure you submit these notes. This is your classwork for today. I'll see you guys tomorrow.